Hi, good day. My name is Nana Isaiah Ibe. I'm bringing forward to you a lecture on GraphPad Prism. I noticed that a lot of us cannot handle our own data, and we choose to give this analysis to people to do it for us. Most of the time, these same persons do not really know how to use this software, and so they do whatever they want to do and hand over this data to us, and we believe that they have done it so well. So I want to give you a short preview on the first things you need to do when you have the GraphPad Prism. And now, GraphPad Prism is not the only statistical software that we have that you use in analyzing data. There are so many of them. Like you have SPSS. Some people are pretty good at SPSS. Some people are pretty good at using even the common Excel. Some people are good at using Minitab and StatCal. But one thing about GraphPad is that GraphPad is mainly for the sciences, the medical sciences. It's very dynamic. It's very good for the medical sciences, and it is easy to use. So today, I'm going to show you the first step when you have your data. After binning your data with Excel, the first two things you must do to determine which statistical package you are going to use in GraphPad Prism. The first thing is to decide if the data you have is evenly distributed. What do I mean by evenly distributed? If your data is skewed to the left or skewed to the right, that is to say there was bias in your selection or in the computing of your data, then obviously you know that the results that you are likely to get with the package you are going to use may be wrong or giving you a false assumption that there is a significant difference. Now, the essence of it is that if your sample passes a normality test, you are going to use a parametric analysis. If your sample does not pass a normality test, you are going to use a non-parametric analysis. Depends on which of the parametric and which of the non-parametric you're going to use. For the parametric analysis, we obviously know that it's broken down into either you're using a t-test, paired or unpaired, or you're using an analysis of variance multiple, or one-way or two-way analysis of variance. For the non-parametric, we know for the t-test, you'll be using a Matt Whitney. For the ANOVA, you're going to be using a Kruskal-Wallis, or you go down to using your chi-square. But for this, we are going to look at your normality test, testing the data through a normality test and running a linear regression to see if our data is linear, and then possibly plotting graph. So join me. This is a simple GraphPad Prism version 8.43. So we have everything open on our desktop. So I'm going to go. You have for the linear graph. You want to run the linear graph, the x and y. You have for the column. You have for the groups. You have for contingency, and so on and so forth. So I'm going to go for the simple column so we can check out the normality of our data. I already have some data sets on my desktop which I binned with Excel. So I will just pick on this data randomly to show you if it passes through the normalities. In some other time, I'll also try to give you a lecture on how to run a straight line graph with Excel to determine the concentration of a solution using Excel, most especially when you are handling ELISA samples. What we have on my desktop now is actually ELISA samples, so that will be for another time. We would look at that. So, but today we just want to see if our data is evenly distributed or not, and if it's evenly distributed, what we have to do afterwards. So these are three variables. Variables, they are independent. So we are going to analyze them now. So we call this control. We call this sample A. and sample B. So what do? My desktop is plain, it's simple, you can see it. You go to analyze. I hope you can see it now. Analyze. You tap on analyze. A small desktop is opened up also, and it's showing you all the analysis that you can possibly run with this, as you can see here clearly. So we are going to go to normality and log normality test. Like I said, we need to check if our if our data is evenly distributed before we decide on which statistical software or which statistical package we have to use based on our design. So here I'm going to, like I said, we're going to use Shapiro weak normality test and the Agostino Pearson test. It's usually good to use more than one. Sometimes some persons will tell you you should use just only one. And here we're going to put on the normal Gaussian curve. I will tell you to create a QQ plot. With the QQ plot, you're going to see how the data they move around the straight line graph to see if it is evenly distributed or not. So we are using Shapiro weak and we are using the Agostino and Pearson omnibus normality test. So it's at 0.05, and so there we go. And here you can see if you use one, like I said, use it's good to use more than one. Shapiro weak is telling us that it didn't pass, and the Augustino and Persona said, yes, 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 it did pass. We would have to look for a tiebreaker here. Now, how do you know it didn't pass? Now, if you look at the p-value, it's usually preferable that any p-value closer to 1 is usually normal. The distribution is usually normal. As you can see, our control, the p-value is not close to 1, is 0.6464, 0.800, and all that. This is an aberrance. That will show you that there's likely going to be a squeezing there. So let's look at the QQ plot for us to really do. Now you can see that all the analysis, all the data you have, they are not in the straight line. They are scattered everywhere. This to tell you that this is not evenly distributed at all. So now that you know that your sample is not evenly distributed, we are going to use a non-parametric analysis. So back to our table, we are going to use a non-parametric ANOVA. So what we do is we go straight to ANOVA. When we ANOVA, we tick and we say okay. There is no repeated measure, so we are not going to repeat. So put it no matching or pairing. So we are going to come down and click use of non-parametric test. So from there, we'll tap on repeated measures. We'll come here to compare. If we're going whatever multiple comparison we want. So we are going to compare the mean rank of each column with the mean rank of every other column. And so you decide on which post hoc analysis you are going to do. So here I'm going to choose to compare the control with every other group here. So I'm going to click on descriptive statistics and graph ranks for non-parametric. Then here we are using Don's test for the post hoc analysis. And I'm going to come here to look at the heat map. So we'll click on the heat map to help us with our graph. But there'll be no need for the residual plot. So I'll go and click on OK. So here it's telling us that there is no significance difference. According to our p-value says anything less than 0.05 is significant. Here our p-value is greater than 0.05, so it is not significant. So there will be really no need to do a post hoc analysis in the first place. But we just initially did that just maybe to go one step ahead. So we look at our descriptive statistics. It shows you everything, your mean, standard deviation, and error of mean. It gives you your minimum and your maximum value according to your confidence interval. And you're looking at your constant confidence interval here. Gives you your upper value, 95% upper value, and 95% lower value, and gives you your mean ranks. So if you look at the Kruskal-Wallis plot, you can see your samples, all of them, according to the way they are stretched out. and this is your heat map. As you move higher, that's how it reduces. When you come down, it's higher here in your samples, and as you move, it reduces. The miss 0 0 mark here is minus, and here is plus, so it increases, 0 decreases in all your samples. So the heat map can be used in exchange for your normal graph if you want. So this is what a typical graph would look like. It's a mean, median, and error. It gives you a mean, median, and error. Um, your, so since simply did a column analysis, there will be no need for us to go over. So now that we have seen that if your sample, if your data is not evenly distributed, what you have to use is a non-parametric test. So in the reverse, if your sample is evenly distributed, you use a parametric. But when it is not evenly distributed, you use a non-parametric. And a non-parametric for ANOVA is Kruskal-Wallis. For the parametric, you're going to use the analysis of variance one way, multiple analysis of variance two way, and so on and so forth. So let's now go back and see if we are handling checking out the mean of two samples. So we're going to create again here, create. So for example, we have your control comparing male and female, male, female. We're just going to put um, um, their weights in kg. So I'm going to put just input like 10, 46, 46, 67, 56, 78, 45, 34, 87, 67, 55, 45, 66, 89. Let's now check if it is evenly distributed. So we'll go the same way and do a log normality test. Okay. So it tells us yes, like I said, if your p-value is closer to 1, and here we can see it's 0.9661 using a Shapiro week. Shapiro week. It says passed the normality test. Yes, 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 yes. 6 numbers. So we're going to go ahead to do a simple t-test here on this analysis. So we're going to the table to analyze t-test. Now you'll be wondering when to use a paired and unpaired. You are looking at two sexes, male and female. You're looking at their weight. There's nothing connecting both of them, so it's actually unpaired. If you had taken a sample from a human being in the morning and you are taking in the afternoon, that's a paired sample because there's correlation. It's one person's sample. What just differentiated it is the time interval which you have taken it. So you have a co-resting phase and then the excited phase. It depends on what you have. You are treated on what you are trying to measure. So at that point it is paired. But at this point, just comparing male and female, there is no link, so it's unpaired. So we are using an unpaired t-test. So and it is parametric. We'll still go using the heat plot and the QQ plot. So our option, one-tailed or two-tailed, so we use two-tailed. We'll look at the descriptive statistics. We'll check for the confidence interval also. And then we click on OK. Now it tells us that it is not significant. Not significant, it says. There is the paired and there is the unpaired t-test. So if you are using, let's say your data doesn't pass the normality test, you are going to use a non-parametric. So that will be Matt Whitney. If you're going to use Matt Whitney, you just click on unpaired and it takes you straight to Matt Whitney and you run your analysis. And Matt Whitney runs analysis based on the median. Um, that is that for today. I hope that next time I'll be able to go deeper to show you how to run a straight line graph to determine the concentration and also to get your R values out of the straight line graph. Um, I hope you've learned something today. Thank you so much for sticking to my channel. I still remain yours, Nana Isaiah Ibe. I'll be with you same time next time to give you an insight on how to analyze your ELISA using your ELISA data using an Excel and also running a straight line graph to calculate the concentration of your ELISA. Thank you so much. Bye.